I'm Joanna Marisi Foronda from BSIT 1A, and I'm going to explain and demonstrate the number system. What is number system? A number system is a mathematical framework or notation for representing numbers using digits or symbols in a consistent way, defined by a specific base like base 10 for decimal. The position of a digit determines its weight, which is a multiple of the base. Common types include decimal, base 10 using 0 to 9, binary, base 2 using 0 and 1 used by computers, octal, base 8 using 0 to 7, and hexadecimal, base 16 using 0 to 9 and A to F. Different number system: A. Binary to decimal, B. Decimal to binary, C. Decimal to octal, D. Decimal to hexadecimal, E. Hexadecimal to binary. A. Binary to decimal. To convert a binary number to decimal, write out the binary number and assign each digit a power of 2 starting from the rightmost digit with 2 and 0, which is 1, and increasing the power by 1 for each position to the left. Then multiply each binary digit by its corresponding power of 2 and add all the results together to get the decimal equivalent. Here's a step-by-step example for the binary number 10110. Write the binary number and powers of 2. List the powers of 2 from right to left, starting with 2 and 0, which is 1, 2 and 1, which is 2, 2 and 2, which is 4, 2 and 3, which is 8, 2 and 4, which is 16, and so on. Align the binary digits with their corresponding powers of 2. Binary 10110 powers 16, 8, 4, 2, 1. Multiply each binary digit by its power of 2. 1 times 16 equals 16, 0 times 8 equals 0, 1 times 4 equals 4, 1 times 2 equals 2, 0 times 1 equals 0. Add the results. 10 plus 0 plus 4 plus 2 plus 0 equals 22. Therefore, the binary number 10110 is equal to the decimal number of 22. 1 times 2 raised to 3, 0 times 2 raised to 2, 1 times 2 raised to 1, 0 times 2 raised to 0, 1 times 1 raised to negative 1, 1 times 2 raised to negative 2. B. Decimal to binary. To convert a decimal number to binary, repeatedly divide the decimal number by 2, recording the remainder 0 or 1 at each step. Continue this until the quotient becomes 0, then write the remainders in reverse order from bottom to top to get the binary equivalent. Here the details steps. Start with the decimal number you want to convert. Divide the number by 2 and note the remainder, which will be either 0 or 1. Take the whole number result, quotient, from the division and repeat the process. Divide it by 2 and record the new remainder. Continue this process with the new quotient until you reach a quotient of 0. Write the recorded remainders in reverse order, from the last remainder to the first. This sequence of 0s and 1s is the binary equivalent of the original decimal number. Example, convert decimal 10 to binary. 10 divided by 2 equals 5, remainder 0. 5 divided by 2 equals 2, remainder 1. 2 divided by 2 equals 1, remainder 0. 1 divided by 2 equals 0, remainder 1. Write the remainders from bottom to top. 1010. So the decimal number 10 is 1010 in binary. C. Decimal to octal. To convert a decimal base 10 number to octal base 8, repeatedly divide the decimal number by 8, recording the remainder each time. Continue this process with the quotient until the quotient becomes 0. The octal equivalent is formed by writing these remainders in reverse order from bottom to top, with the first remainder being the least significant digit and the last remainder being the most significant digit. Step to convert. Divide by 8. Divide the decimal number by 8. Record remainder. Note to remainder from the division. Use quotient. Take the quotient and use it as the new number for the next division. Repeat. Continue dividing by 8 until the quotient is 0. Write the remainders from bottom to top. 534. So 348 is the decimal is 534 in octal. Example, convert 348 decimal to octal. 348 divided by 8 quotient equals 43. Remainder is equal to 4. 43 divided by 8 quotient equals 5. Remainder equals 3. 5 divided by 8 quotient 0. Remainder equals 5. Write in reverse. The octal number is formed by reading the recorded remainders in reverse order from bottom to top. D. Decimal to hexadecimal. To convert a decimal base 10 number to hexadecimal base 16, repeatedly divide the decimal number by 16, noting the remainder at each step. Continue this process until the quotient is 0. The hexadecimal representation is formed by writing the remainders in reverse order. Remember that remainders of 10 through 15 are represented by the hexadecimal digits A through F respectively. Step for decimal to hexadecimal conversion. Divide. Divide the decimal number by 16. Record remainder. Note the remainder from the division. Repeat. Use the quotient as the new number and repeat the division process. Continue. Keep dividing until the quotient becomes 0. Write hex value. Arrange the remainders in reverse order to get the final hexadecimal number. Convert remainders. For any remainder from 10 to 15, use the corresponding letter A for 10, B for 11, C for 12, D for 13, E for 14, F for 15. Example, convert the decimal number 255 to hexadecimal. 1. First division. 225 divided by 16 equals 15 with a remainder of 15. The remainder 15 is represented by the hexadecimal digit F. Second division. 15 divided by 16 equals 0 with a remainder of 15. The remainder 15 is represented by the hexadecimal digit of F. Combined in reverse order, the remainder read from bottom to top are F then F. Therefore, 225 decimal is F and F is hexadecimal. Hexadecimal to binary. To convert hexadecimal to binary, break the hexadecimal number into individual digits and replace each digit with its corresponding 4 bits binary equivalent using a standard conversion table. For example, F hexadecimal becomes 1111 binary and 2 hexadecimal becomes 0010 binary. Then join 4 bits group together to form the final binary number. Here the step-by-step process. Separate the hexadecimal digits. Divide your given hexadecimal number into individual digits. Convert each digit. For each hexadecimal digit, find its equivalent 4 bits binary presentation. Combine the binary groups. Write down the 4-bit binary equivalents for each hexadecimal digit in the same order as the original hex digits. Maintain leading zeros. It's crucial to keep all 4 digits for each binary equivalent, including leading zeros, to ensure the correct conversion. Example, convert hexadecimal 2C to binary. Separate. The digits are 2 and C. Convert 2. The binary equivalent of 2 is 0010. Convert C. The binary equivalent of C, which represent 12 in decimal, is 1100. Join this gives 00101100. So the hexadecimal number of 2C is equivalent to 00101100 in binary. Here are some example of hexadecimal to binary conversion. Number systems are fundamental frameworks for representing quantities with diverse types like decimal, binary, octal, and hexadecimal serving various purposes. From daily counting to computer operations, they form the foundation of mathematics and technology and enabling precise communication, measurement, and complex calculation, and their understanding is crucial in fields like computer science, engineering, and finance.